Volatility is the degree of variation in price over time. It's not just the direction of the market, but the magnitude of its movements. Sometimes small and quiet, sometimes large and violent, volatility arrives in waves. In calm periods, prices move in a narrow range with small fluctuations. Narrow fluctuations make the market feel stable and predictable. Low volatility means that participants are confident, and risk is perceived as low. These times can last days, weeks, or even longer. In turbulent periods, prices swing with large fluctuations. Volatility spikes, and the market becomes reactive and unpredictable. High uncertainty means that participants are less confident, and risk is perceived as high. These periods can arrive suddenly and last unpredictably. If price changes are random, high volatility should be followed by low volatility. But real markets behave differently. Turbulence clusters. This is one of the most important discoveries in financial data. It changes how we understand risk. Volatility is not evenly scattered through time. It appears in bursts, then disappears, only to return again. Why do turbulent periods cluster together, separated by long periods of calm? This is not a flaw in the data. It is the behavior of real markets. Welcome me to the brand new episode of Econophysics Lab, where we are decoding markets through physics. Science, not guesswork. Patterns, not chaos. Systems, not stories. Understand before it collapses. Physics reveals what markets hide. In the 1990s, researchers analyzing financial data found something surprising. Volatility was not random. It clustered. This observation changed the way we understand markets. When a large move happens, the next few days are more likely to also be large. This is clustering. Volatility clusters in time, not randomly. This is the first signature of volatility clustering. When a small change happens, the next few days are more likely to also be small. This is clustering. Low volatility clusters in time, not randomly. This is the second signature of volatility clustering. Volatility clusters across time. Minutes, days, months, decades. The pattern survives when the timescale changes. Volatility clustering is not a quirk. It is a universal property of real financial markets. Across assets, across timescales, clusters return. This is the fingerprint of real markets. Randomness and clustering. Two very different worlds. Only one matches real markets. Randomness assumes the future is independent of the past. Clustering reveals the future is influenced by the recent past. Markets are not memoryless. They remember past events. A shock occurs, information enters the market, and the memory fades over time. But it never disappears completely. Can we detect market memory? Can we measure it? Can we use it? Markets may look random, but randomness does not mean no memory. Our job is to find the fingerprint of memory in the waves. Markets remember volatility far longer than direction. The market quickly forgets whether prices went up or down, but volatility memory persists. Markets don't forget volatility immediately. They carry echoes of uncertainty. These echoes create the waves we observe in real market data. Stressful times change the market. The impact doesn't vanish instantly. Stress leaves traces in the market state. Those traces make future waves more likely. Volatility shocks do not vanish quickly. They decay slowly, leaving a long shadow. This memory creates clusters of volatility. Markets remember the magnitude of shocks, not their direction. This memory doesn't predict future returns but conditions them. The level of uncertainty stays elevated for a while. Energy is released in bursts, not in a steady flow. The world is intermittent, nonlinear, and unpredictably bursty. Markets are part of nature, and they inherit these dynamics. Storm systems don't release energy smoothly. They build, intensify, and release in waves, creating a dynamic and powerful force of nature. From formation to dissipation, each stage plays a crucial role in the storm's life cycle. Understanding these patterns helps us predict and prepare for their impact. Ocean waves are never smooth. They arrive in swells, not a steady flow, carrying energy across vast distances. At the shore, we see the culmination of this journey, where waves break and release their energy. This rhythmic pattern is a testament to the ocean's power and complexity. Earthquakes release energy in a main shock, followed by aftershocks, creating a cascade of waves. This process is a natural release of built-up tension within the Earth's crust. Understanding these patterns helps us anticipate and mitigate their effects. Fluid flow isn't smooth. Energy cascades from large eddies to smaller ones, dispersing across a wide range of scales. This turbulence is a complex dance of energy, shaping the behavior of fluids in motion. Recognizing these patterns is crucial for understanding fluid dynamics. Nature doesn't release energy slowly. It stores, builds, then releases in bursts, creating a dynamic cycle of accumulation and release. This burst cycle is evident in various natural phenomena, from lightning to avalanches, showcasing nature's unpredictable power. Across scales and systems, energy is not released smoothly. It appears in waves, bursts of activity separated by quieter periods. This principle is evident in various natural and market systems, highlighting the interconnectedness of different phenomena. The market does not behave the same way all the time. It transitions through different states, from calm to turbulent, reflecting the underlying dynamics. Understanding these states helps us navigate the complexities of market behavior. Markets can spend long periods in calm, stable states. However, this stability is not permanent, as underlying forces can shift, leading to changes in market behavior. Recognizing these periods of calm helps us prepare for potential volatility. When volatility rises, markets enter unstable states where energy is released in bursts. This turbulence is not random, it's a state of the system, reflecting the underlying dynamics. Understanding this helps us anticipate market shifts. Markets do not jump from calm to chaos. There is momentum and a path that leads to turbulence. Recognizing these transitions is crucial for understanding market dynamics and preparing for potential changes. Once a market enters a turbulent state, it can remain there for extended periods. Instability is not a moment, it's a state that can persist, reflecting the system's memory and dynamics. Understanding this persistence helps us navigate uncertain times. Risk does not remain constant. It moves in cycles of build, amplify, peak, release, and recede. These waves of risk are a natural part of market dynamics, reflecting the underlying forces at play. Recognizing these cycles helps us manage risk effectively. Markets are dynamic systems that move through different states, from calm to turbulent, and back again. This cycle continues, driven by various factors that influence market behavior. Understanding these regimes helps us anticipate and adapt to changes. We cannot predict the future, but we can estimate the odds. By analyzing patterns and understanding the underlying dynamics, we can prepare for potential outcomes. This approach helps us navigate uncertainty with greater confidence. Forecasts fade over time as uncertainty compounds, making it challenging to predict market behavior accurately. Recognizing the limits of forecasting helps us focus on preparation and adaptability rather than certainty. Signals inform us of potential changes, while events transform the market landscape. Understanding both is crucial for navigating market dynamics and making informed decisions. Recognizing the difference between signals and events helps us stay ahead. Fragility is weakness hidden in normal times, waiting to be exposed by shocks. Detecting this fragility helps us prepare for potential disruptions and build resilience. Understanding these hidden vulnerabilities is key to navigating uncertain environments. You cannot predict the future, but you can understand where you are right now. By assessing the state of the system, we can prepare for potential risks and adapt to changes. This understanding is crucial for navigating complex environments. Bubbles are not just stories, they are outcomes of feedback, leverage, and collective behavior. Understanding the physics of market bubbles helps us recognize patterns and prepare for potential bursts. This insight is crucial for managing risk and seizing opportunities. We will be exploring this in our next episode in the Econophysics Lab. Physics reveals what markets hide, offering insights into complex systems and dynamics. By decoding markets through physics, we gain a deeper understanding of the forces at play, helping us navigate uncertainty with greater clarity. Like, share and subscribe for more such insightful episodes.